All right, this is a key for homework 5. I posted the paper version of this, and I'm going to walk through the video part. So we're going to do benefit cost ratios. And some people were confused by that again, right? That's just saying the discounted, right? For every time period, you discount all future benefits and put that over all future costs discounted. That's the one there, and you come up with a benefit cost ratio. So we have a problem here, problem 1, where we're a manager of a state agency, and we've been presented with 4 potential projects. We have a new fire tender from quiz 1. We have upgraded campground from class, rustic campground from class, or 100 acres of forest plantation starting from bare land. This would be like our homework for problem 1. Your agency uses a 6% discount rate, annual of course, and you have a budget in this case of $500,000 for the year's projects. Note that the annual budget money allocation does not need to be spent in the current year because we're talking about all these discount things, right? You can put it in the bank and earn the 6%. So we can put that money towards projects that we have in the future. And so what we have here in 1A is the potential where we're going to rank these projects. So what the project is, what the benefit cost ratio is, and what the present value of the costs are. And then which of these projects would we undertake. So if we flip over to the first page here, we have the fire tender problem. So it's a little different than what we did on the midterm. Right, so let's read through it and figure it out. So, an agreement to provide a fire tender services to a local landowner group. To do so, you will need to buy a new tender, a truck with a water tank. That's going to cost you $200,000 now, and it's going to require annual maintenance expenditures of $1,000 per year, and that starts at the end of the first year, and an additional cost of $5,000 every fourth year, shouldn't say years, starting at the end of the fourth year. Right, the annual revenue we're going to receive is $50,000 per year. What's the benefit cost ratio of this agreement in perpetuity? So because it's perpetuity, I know that this is just going to go on and on and on. We're going to buy this thing, we're going to assume we can run it forever with that maintenance program that we have. So what do we have here? We have under our benefits and our costs. We start at year 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and on and on and on and on and on. For benefits, we're going to get, starting at the end of the first year, $50,000 every year, on and on and on. And for costs, we're going to have minus 1, minus 1, minus 1, minus 1, minus 1. But then every fourth year, 1, 2, 3, 4, right? And 10, so there's 8, we're going to have 5, minus 5, minus 5, 12, minus 5, right? And those ones go on and on and on. So one of the things about the benefit cost ratio is that you need to keep costs and benefits separate. And so let's do costs first. So, right, our costs, we have initial. And that one we already know that the VO is already here. It's minus 200. We got to buy it right now. Minus 200. And what I'm going to do here as well with these minuses, since I'm calling it costs, I'm just going to get rid of them. So it's just going to be $200,000 of cost. Then I have annual maintenance. And that one is this minus 1 that happens every year. So over here, it's not single, it is every year, goes on forever. So this is this VO equals A over I. So if we have VO equals A over I, and we know that A equals 1,000 and I equals 6%, we can do that as 1,000 over 0.06, or a cost of $16,666.67. So we got 2 of our costs done. We have one more up here. It's the periodic one with the 5,000. So periodic maintenance. And that one right? It's not one time again, it's going to go on forever. It's not every year, it's every N years, forever. It's this one that we spent the last homework doing a lot of things with. So, and that one is VO equals A over 1 plus I to the N minus 1. And our A here is 5,000, our I is 6%, and our N is every 4th year. And so if I do my VO equals 5,123 over 1.06 to the 4 minus 1, we'll bracket that so it works. And what I get there is 19,049.29. So I can do my costs. They're going to equal 200,000 plus 16,666.67 plus 19,049.29, or my costs equal 235,71596. Boom, boom. So costs done. Let's see if we can get that a little clearer for you. Okay, then we move on to revenue. So revenue in this case is our benefit associated with this. Multiple benefits probably, because we're not buyer benefits, but we're not going to count those here. And that's every year we get 50,000. So just like this one that's annual maintenance, we're looking at VO equals A over I, where our A is 50,000 and our I is 6%. And so we have 50,000 over 0.06, or benefits of 833,333.33. And so we can do our benefit cost ratio now. So I'm just going to call that my BCR, and it's my benefits, right, which are the 833.33, and over our costs, 235,71596, and that gives me a benefit cost ratio of 3.54. Boom, boom, boom. Okay, so that's the first one that we had. So, right, we could put it on our table now, but I'm going to rank them before I put them in the table. And so I'm going to move on to the second part. And the second part here is upgraded campground facilities. So this is hookups, restrooms, that sort of thing. It's going to require an initial investment of $250,000 now, and required maintenance costs of $4,000 per year starting at the end of first year, and $50,000 every 5 years starting at the end of the 5th year. So you expect 3,300 overnight visitors. You're going to charge $45 per night. What's the benefit cost ratio? So this one actually looks a lot like this one up here, in that we have benefits that are just this annual thing. We're going to call them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to call them just B's. And these B's, these benefits, occur every year there on out. And now we need to know our costs. We're going to have annual costs, A, and so on and so on and so on, and we have periodic costs. So this is $50,000 every 5 years. Call them P, right? So that goes on and on. Oops, that's a P. They go on and on and on. So that's what our timeline would look like here. And so it is essentially like this one. And just like this one, where the first payment for the maintenance was at the end of the 4th year, so that the start of the series was right there, that's the same thing here. So, right, we'll think about that as we go through. So we can do costs, same way we did it before. We have initial, and that initial cost is VO equals 250,000, and we have an annual cost, and on that one it is, right, VO equals A over I, just like before. It's that annual one, but this A is going to be $4,000 per year, and the I again is 6%. So we have 4,123 over 0.06, which equals 66 666. I should have chose something that didn't give all these funky decimal points and weird numbers. Okay, so, and then periodic. Okay, so just like before, we have every 5 years, so it's a lot like this one up here where we have periodic maintenance that way. And it's just going to be where our A is, in this case, $50,000, because we're going fancy. The N is 5, and the I is 6%. And we have VO equals A over 1 plus I to the N minus 1, just like we had up here. And so we can go ahead and plug that in. VO equals $50,000 over 1.06 to the 5 minus 1. Or VO equals 147,830.33. So we can do our costs now that they're all in the initial period, right? We didn't have to move that anywhere because the start of this first period, right, because it happened 5 years out, was right there. So everything was solved to the right point. We have 250,000 plus 66,666, very devilish, 67 plus 147,830.33, or costs of 464,497.00. Pretty odd how we get the nice even integer there at the end. Okay, that's costs, benefits. Just like this other one, we have this annual benefit that's occurring, and what we have there is going to be VO equals A over I, just like up here. And the A in this case is going to be 3,300, right? Overnight visitors paying $45 per visit. So visitors, visits, and ends up with dollars. That works nice for us. And 0.06 is what we're going to put it over. And so we get 2,475,000.00. So now we have our benefits and our costs. We've summed them up, all the discounted values to that present period, and we can do our BCR. And it's going to be the benefits, right, which are just 2,475,000 over costs, which are 464,497. And when we do that, we get 5.33 as our benefit cost ratio. So that's the first one here and the second one, but we have 4 options to do. So let's move forward to our next one. Rustic Facilities. So this one is obviously a lot like the fancy one, it just has smaller numbers. And so, right, we're going to have just peeing on the trees, I guess. $75,000 now, maintenance of $400 a year, and $7,000 every 4 years, starting at the end of the 4th year. We get more visitors in this case because we can have more spots, but they don't pay as much per night. And again, this goes on in perpetuity. So our timeline just like looks just like that other one, where we have benefits and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and on and on and on. Right, and we have, let's call them B, 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 B. Benefits are coming in every year. Costs, right, we have our big initial here, and that's that 75,000, and then we have annual costs every year, and we have periodic costs every 4 years. So P, 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 and on and on. Okay, so if we were doing that present value, of course, we could combine that B and A because they're in every period. But because we're doing cost-benefit analysis or benefit-cost analysis, we need to keep them separate. So we can't do that. Luckily here, it's just that VO equals A over I. So it's not as big of a deal. But let's do our costs. We have initial, and that is VO already, $75,000. Right, and then we have annual. We won't go through looking at the equations. We know what they are. It's VO equals A over I, just like the other ones. The A in this case is $400 a year. And the I is 0.06 for this entire thing. We're going to use that same discount rate. And when we put VO equals A over I, we get 16,666.67. And that's not right. That's $1,000. Because I'm doing E. Yeah. Cross that part out. It's 666.66, right? It's just 10 less than that. I got on the wrong page there. So periodic. And for our periodic, we have our VO equals A over 1 plus I to the n minus 1. And when we do that, and we plug the A in this case is the $7,000. And 1.06 to the n here is every 4 years to the 4 minus 1. We get a VO equal to 26,669.01. So now we can put our costs together. And so we have $75,000 is the initial cost plus 666.67. There should be an extra 6 in there, and plus 26,669. And this homework brought to you by the number 6. And for the total cost, then I get 108,335.67. So that's our costs. Now we move on to our revenues. And our revenues are just going to be that VO equals A over I, where our A is going to be 9,125 visits per year times $12 per visit. And we put that over 0.06, and we should get 1,825,000. That's our revenue. So our BCR in this case is going to be the revenue 1825000 over the costs 108,335.67, or that BCR is 16.85. Big bang for the buck, right? For every dollar we spend, we are going to get $16.85 in return. Okay, so that's option 3. We have 4 options to do. So this last one is plantation. So we're going to file this 100-acre business in the back of our mind for now and just work on a per acre basis. Reforestation company charges $200 an acre for planting. You have a cost associated with reducing stand density, so like a pre-commercial thinning, at $160 per acre. That's going to happen at year 10. We have a thinning that's going to give us revenue, $1,500 per acre at year 30, and the final harvest at 40. And so what we have here, right, if we go on and on, so there would be 80, 40, not 45, and that sort of thing, right? We have this benefit and cost. And so cost, we have plant, right? And at 10, we have T1, let's call it, that's our little thin one. Out here at 30, we have on the revenue side, T2, and final harvest. Final harvest comes when there's a plant, and then there's a T1 again, and out here at 70 at 50, we have this other thinning right before the second one, so T2, F, right, P, on and on. So if you remember when we did this, we knew we had periodics, right, that we were moving. And this is the one where we made an A that was going to be sliding all of these out to the end of the period. We can do that again here. So, right, we knew that we were going to use something like this. VO equals A over 1 plus I to the n minus 1, right? We knew that this whole rotation thing is a periodic thing that goes on forever. So it is this equation, right? And we just want to make things simpler. So if we know this up front, we can do our costs and do it the same way. We want to know what the cost A is out here. And so to do that, we can take this P and move it out there, just like we did in the homework. So if we have an A there, we can take $200 per acre times 1.06 to the 40, right? And so that's just our single moving the future value. So we take our VO and we make it a V40 essentially, because we want it out there for our periodic equation. And we can add to that this T1, we need to move it out 30 to get it out here at the end. And that's $160 per acre times 1.06 to the 30. And if we do that, right, where we sum that together, we get 2976.10. So that's what we have as an A. This is our VO. So our I is 6% and our N is 40. And we can go ahead and just plug this in. So we have 2976.10. That's the A we computed by moving all these out here. And we put it over 1.06 to the 40 minus 1. And that gives us 320.50. That's per acre. So we're going to multiply that, right? So this is per acre, not acres, times 100 acres. And that's going to equal then, down here, our VO for the cost of 32,050.32. Present value of the cost. So we're going to do the exact same thing with the benefits in this case. So the benefits, we know we want an A out there at the end of 40 years. And so with this T2, the second thinning, that's the $1,500 at age 30. So we need to move $1,500 times 1.06 to the 10. And that slides it 10 out here. And then we can just add on to that the 8400, which gives us an A of 11,086.27. So I'm doing the exact same thing here, and then I'm moving these out to there where I can add them together, and then when I apply my perpetual periodic that I'm using for this, I just apply it once. So VO equals A, in this case 11,086.27 over 1.06 to the 40 minus 1. Or the VO for the benefits in this case equals 1193.91, and that is dollars per acre times 100 acres equals 119,390.57. So got our VO for our benefits. So now when we do our BCR, benefit cost ratio, we're going to put those benefits, 119,390.57, over the costs, which are 32,050.32, which gives us a benefit cost ratio of 3.73. Right, so now we have a benefit cost ratio for each of our 4 options. And so we can go back to our original table where we wanted to store this information. So if I bring that back now, and I'm looking at it here, I can rank them. And so first thing I'm going to do is look for the highest benefit cost ratio. So I've got these 4 options here. This is definitely the highest, 1685 for our rustic campground right there. Second highest one is 5.33 for the fancy campground. Third highest is going to be 3.73 for the forestry, and the fourth highest is the water tank at 3.54. So I'm going to put those into my table, right? Rustic camp, and that's 16.85, And the present value of the costs is 108,335.67. So that's just right when I was gathering that information up here, that's where this came from, right? So this is the cost that I used to create my benefit cost ratio. So if I do my fancy camp, right, that was our second one at 5.33 benefit cost ratio, and the present value of the cost for that were 464,497.00. And our third one was the Plantation, our trees, and that one had 3.73 and 32,050.32 for costs. And the last one was our fire tender. And that one didn't have quite as good. It was at 3.454. Still a pretty good investment, I must say. And 235, 715.96 were its costs. So the last thing I'm going to do is figure out, I have $500,000 to spend. I've calculated the benefit cost ratio, figuring out the most bang for the buck and what that actual budget would be. So with $500,000 to spend, right, if I picked number 2 here, the fancy camp, that's all I can do. Well, I guess I could do this one on top, right? I could have 2 of these, but I'm going to pick this one first. It's 1685. So I know I'm going to do rustic camp, right? Because that's going to be the best one, and that gives me $108,000. So I've still got a bunch of money in my bank account. I can't do this one because that would put me over my $500,000, but I can definitely do the Plantation. Right, and that's another $32,000, so now I'm up to $140,000, and I can do this last one as well for $235,000. And so fire tender. And so that's what I do. So those are the 3 projects that I can take, and hopefully that helps you guys with understanding how we use benefit cost ratio.